Thanks very much, Will. That was a very kind introduction. Will's asked me to give you essentially a whirlwind tour of the legislative drivers for reducing embodied carbon. Now, I'm obviously not going to cover every policy in the world in the next 15 minutes, but I want to give you an overview of different approaches and recent trends. The slides are purposefully a bit dense, so you can download them afterwards and follow the links for more information. Now, I'm going to start globally with the Paris Agreement, and then work down through examples of different national policy responses, some of those from cities and local authorities, and the implications for structural engineers. Now, I've been asked to focus exclusively on embodied and whole life carbon policies as opposed to those targeting operational carbon. So for this presentation, think materials and plant. I won't be talking about heating, lighting, or cooling, or any of those kinds of issues. So 6 years ago in Paris at COP21, almost every nation on Earth agreed to an international treaty to limit any rise in global temperatures to well below 2 degrees above pre-industrial levels and pursue efforts to limit it to 1.5. Now, essentially, the agreement functions around a 5-year ratchet mechanism whereby countries submit their plans, what are known as nationally determined contributions. These are added up in a global stocktake, and any gap between our global goals and our collective plans becomes the subject of negotiations. Now, at the time of the Paris Agreement was signed, those plans put us on track for greater than 3 degrees warming, with global emissions growing substantially out to 2030, along the kind of grey projection you can see on the graph there. Since then, signatories representing just under half of global emissions have revised their nationally determined contributions, so that's bringing us down to something like the blue range. However, those commitments still imply global emissions in 2030 would be higher than in 2010. And if we zoom out, you can see the enormous near-term gap that remains between those nationally determined contributions and the emissions pathways required to achieve our temperature targets. So that's the gap that the ratchet mechanism is intended to close. And the implication is that as an engineer, you should be expecting many of the national emissions targets that have been put forward to date to be further strengthened in future to close that gap. That is the whole purpose of this agreement. We've already seen, for example, earlier this year, the UK effectively brought forward its old target by 15 years. And if your country has a long-term net zero target date, I'd strongly advise planning to meet that 5 or 10 years earlier, because it's highly likely that the targets will catch up. Now, if we look further out into the future, countries representing nearly 3/4 of global emissions have now announced some form of long-term net zero target. If you take an incredibly optimistic interpretation of those targets, as has been done for this recent climate action tracker update, then we could still be heading for something more like this orange pathway. I'm assuming you can see my cursor here, with steep emission reductions mid-century delivering closer to 2 degrees of warming. So the 2-degree goal isn't entirely out of reach. We just need to accompany delivery of these long-term targets with much greater near-term action. And I expect we'll see further announcements to this effect in the run-up to COP26 in Glasgow. Now, according to the International Energy Agency, operation of the built environment currently accounts for about 28% of global emissions, and the construction industry and its material supply chains, another 10%. Now, there are different estimates for this. Some of the alternative estimates give you a figure closer to 20%. So typically I'd say 10% is a kind of lower bound, somewhere in the 10 to 20%, depending on the level of construction activity in any given year, and whether you include things like the impact of transporting construction materials. More generally, industrial materials production for all applications accounts for closer to 1/4 of global emissions, a substantial proportion of which comes not from the energy sources, but from essential chemical processes. So if we're planning on building a new area the size of Paris every week, whilst retrofitting all our existing buildings and infrastructure to operate in a net zero future, then demand for these materials could increase substantially. Now, some estimates suggest global material stocks could rise to about 4 times today's levels during the period in which we need to achieve net zero emissions. So faced with that dilemma, policymakers have to act to reduce the impacts of construction supply chains. And broadly speaking, they've got 2 options: supply side policies that support decarbonisation of material production, or demand side policies, which stimulate demand for low carbon products and encourage changes in design. Now, this little 3-stage graph is kind of a neat way to think about the problem. Essentially, so far, we've been at the first stage of prioritizing policies for specific materials on the supply side. So you can think of all the investment in new technologies, hydrogen steel making, carbon capture and storage, and so forth. Now we're moving into the second phase of introducing more materially neutral policies on the demand side, which are designed to accelerate this market growth for low carbon products. So things like public procurement requirements and embodied carbon regulations fall into that kind of bucket. Ultimately, we need to get to the third stage on this graph, where we start using policies like building regulations or border carbon adjustment mechanisms to eliminate the worst offenders. So really all the new regulations on embodied carbon I'm going to talk about in a moment are part of this much broader trend of accelerating up that curve. Now, embodied carbon is a very complicated and rapidly developing area of policy. Just to give you a sense of that speed, back in 2017 and 2018, these two excellent international embodied carbon reviews were published, and they covered the details of a bit over 100 rating systems and regulations. Now, in just 3 years, these are now essentially entirely out of date. And if you tried to write a new version now, that would probably be out of date by the time it was published. What we're seeing is a plethora of different emerging policy responses. Now, most of these are driven by some degree of quantification of embodied carbon, at either the product or the building scale. And typically, this will be asking for environmental product declarations showing the impacts of the product specified, or a life cycle assessment showing the impact of a building. Now, this disclosure might be accompanied with targets, say a particular carbon intensity per product or floor area, or in some cases, just qualitative statements indicating how you've tried to minimize the impacts of your design. Embodied carbon is also increasingly being mentioned as a factor behind adoption of lots of related policies, targeting particular design options or setting preferences for things like retrofit first. And there's also a wide range of policy instruments being used, most commonly some form of public procurement requirements, planning requirements, building regulations. And whilst the basic principle of measure the embodied carbon and reduce it is fairly simple, we're still seeing a lot of variation in methodologies for assessment, most of which still conform to a set of European and international standards. So for instance, some locations are opting for a single assessment methodology you can use across all buildings. Others are differentiating by size or function and using simplified methodologies to reduce compliance costs. Most regulations are based on static life cycle assessment, but the French are now becoming the first to introduce a dynamic element, essentially giving a greater weighting to carbon that's emitted today than in the future. And the way in which natural materials and sequestered carbon are handled varies from place to place. For instance, I'd be curious to know how many people on this call know the difference between a carbon footprint and a carbon handprint. We're getting an explosion in all this kind of terminology. It's an increasingly complex policy landscape where the devil's often in the detail, and there's going to be a lot of room for future rationalization where we bring these together and standardize approaches a bit more. So this table is just a few examples of the European countries that have introduced or are currently developing policies which require quantitative assessment and limitation of embodied impacts. You can look at the details, follow the links in these slides afterwards. I strongly encourage you to do so. What I want to do just now is just draw out some of the common trends, because over the next 5 years, we're essentially going to see a big natural experiment wherein lots of countries adopt slightly different approaches to assessing and reducing embodied carbon. Now, generally, these approaches start with the development of common enablers, so such as a national assessment methodology, databases of product impacts, and software tools to support assessment. Once these enablers are in place, assessment requirements will be introduced with results reported into a common repository, and that data will go on to form the basis of a series of benchmarks or limits against which future projects will be assessed at some point in the future. Now, that whole process of going from announcing an intent to tackle embodied carbon to establishing limits on projects, that seems to typically be taking several years to get through. So for instance, in Finland, back in 2016, their Ministry of the Environment started developing a roadmap for low carbon construction that ultimately set out the desire to take account of a building's carbon footprint. They developed a national methodology for assessing and reporting whole life carbon emissions over the subsequent years, with a fairly extensive piloting and consultation phase. Earlier this year, they published the emissions data set that will be used for the assessments, and they recently closed their consultation on a revised regulation and methodology. Now, those new requirements will be incorporated into the upcoming reforms of the Land Use and Building Act, with the intention that there'll be limit values for different building types in place by 2025 at the latest. And they published a paper around those limit values earlier this year. Though I believe the intention is that they'll be rolling this out earlier across publicly funded projects. Now, that general approach and journey I've outlined there is currently being emulated by a handful of countries. As Will mentioned earlier, if you're keen on supporting the introduction of something similar in the UK, then I'd highly recommend going to partz.uk. The website, as Will mentioned, includes statements of support for the regulation of embodied carbon from all of these household names and many more. Will, myself, and the other PartZ authors would very much welcome adding your name to that. Now, whilst several European countries have adopted this approach of regulating through assessments at the building level, across the Atlantic, they're instead prioritizing public procurement requirements. So this approach really started with the Buy Clean California Act back in 2017, which essentially sets limits on the carbon intensity of specific materials on public works. Now, the products used must be below these limits, as demonstrated by submitting environmental product declarations. So this general Buy Clean approach of disclosure combined with standards, and in some cases incentives, is now being emulated across the US. So for example, Colorado signed a similar bill earlier this year, and a proposed federal version is now in front of the House committees. So I'd highly recommend the toolkit I've linked to there from the Carbon Leadership Forum if you want a great overview of everything that's happening stateside. Just for context, with that focus on public procurement, it's been estimated it's about 1/3 of embodied carbon from construction in the US over the past projects that's been attributed to public projects. Now, the principal advantage over the kind of more European approach is that it's much simpler to demonstrate compliance, as it doesn't require you doing a full carbon assessment or having the associated skills to do that. But critics will obviously argue that the downside is you don't really have to demonstrate holistic design or efficient use of materials as long as they're being procured from a better than average producer. And arguably, having policies focused solely on public procurement presents a risk of simply diverting all the greener materials from private projects into public works. So frankly, it's too early to tell how it's going to play out in practice, this policy approach. And we'll see the proof in the pudding over the coming years. Of course, in addition to national policies, there's a really rapidly expanding array of actions being taken by cities and local authorities. This report from the Carbon Neutral Cities Alliance is an excellent overview of different approaches that can be adopted at the local level. I'd also highly recommend C40's Clean Construction Policy Explorer that's linked to there, which gives you a nice interactive list of examples from a really broad range of locations. The challenges you can imagine from that graph there, with the rate of change in this space, is keeping all these resources up to date. Just to pick out one recent example from the UK, the new London plan, which came into force in March, now includes a policy requiring whole life carbon assessment. So this new requirement will apply to referable applications. So that's in essence the largest development. So think of 150 housing units or a commercial building over 2,500 square meters, that sort of thing. And the Greater London Authority recently concluded a consultation process on the associated draft guidance and reporting templates for that. Now, as conceived, it's going to have a 3-stage process. So the pre-application stage, you'll be expected to demonstrate adoption of a set of whole life carbon reduction principles, of which I think there's 16, essentially explaining how you're incorporating them into your project and providing some basic project information. The first whole life carbon assessment will then be submitted at the planning stage based on the data that's available at that point. And then that assessment will be updated post-construction with the as-built data. And all of the results will be submitted by building element category and life cycle stage using a common template. Now, I know a number of other UK local authorities are watching this development very closely with a view to adopting similar requirements. So what does this all mean for you? Well, I think there's a few key takeaways for structural engineers. First, within your own practice, expect and plan for more ambitious national mitigation targets. As I was talking about that ratchet mechanism at the top there, that is something you should be anticipating. These will likely translate into some form of embodied carbon regulations over the coming decade. Depending on where you are in the world, that might take more of an American approach. It might be more like what the Europeans are doing. It might be something altogether different. And instead of waiting for those regulations to come and responding, I'd encourage you to get out in front where you can. Start assessing embodied carbon on your projects and thinking about what skills, information, and procedures you might need. And if you're already routinely assessing embodied carbon, then you may want to play a more active role in campaigning for, shaping, or providing evidence to inform development of these regulations. There's going to be an enormous amount to learn from the experiences of other countries, simultaneously bringing in this range of different approaches. And where there's this kind of complexity and rapid change, I think it's right that you expect your professional institution to support you in learning from those experiences. So I imagine the iStruct team will be doing more on this topic over the years to come, and if not, you can pester Will about it. Finally, I'd just like to finish with a very quick ballpark calculation, because I know engineers love those. As a thought experiment, let's say we go on and build the 230 billion square meters of new floor space that the IEA expect us to build over the period out to 2050. And let's say we did it at 1,600 kilos of CO2 per square meter of embodied carbon. Not untypical for UK projects where there's no embodied carbon reduction targets in place. So if you're thinking that number looks high, you're probably one of the people who's been assessing this for a while and reducing it on your project. Just combining those two figures alone together would have an impact of about 368 gigatons, and that's larger than the entire remaining 360 gigaton global carbon budget for 1.5 degrees. So that very simple and crude math indicates why it's absolutely essential that we start driving embodied carbon out of our designs. And the policies to support that will inevitably follow. Responsible engineers should be getting out ahead of this, using all the great resources that Will just flagged from the iStruct team. So thanks very much. I know that's an awful lot to take in. Please have a look at the slides afterwards, click through the links, have a read of what's going on, and get in touch if you've got any questions about it. So thanks very much.
Thank you, Yannick. That really, really interesting whirlwind tour there. Thank you for preparing that for us. And I think, the thing that really stood out to me, of course, is highlighting the fact that countries are not yet on track to meet the 2-degree global warming limit means that whatever policies are in place are only going to be ratcheted down over time. So you should prepare for these things to get tighter and tighter as we go forwards, rather than assuming that we're just going to miss the target. Really interesting. Thank you, Yannick. We're going to hand over to Steve Gilchrist now. So Steve, if you want to get your slides ready. Steve is a project director at Grosvenor, Britain and Ireland. Grosvenor are a really big development company based in the UK. I'm sure Steve will introduce themselves better than I could. But we asked Steve to come along because Grosvenor is doing some really interesting work around firstly setting themselves some nice ambitious carbon targets on everything that they build, which Steve will likely touch on. And secondly, pushing research in the field of circular economy, which we're going to touch on a bit more next week at day 2 from Penny Gallagher's going to talk about circular economy specifically. But we thought we'd ask Steve along to give us a bit of an overview of some of the work he's doing at Grosvenor and help put you in the position of a client for 15 minutes, help you understand how they're seeing all of this at the moment, in the hope that it can help you work out what you need to do next on your next project with your next client. So Steve, if you're happy to put your screen up, we can hand over to you.
Okay, so yeah, I'm Steve Gilchrist, project director in the development team. I work on projects in Mayfair and Belgravia on our London estates. If I say GBI, that's Grosvenor, Britain and Ireland, so just bear with me on that one. I've called this Think Zero a brief look. Clearly, I'm trying to play on the word brief there about how we set our brief and what we want our projects to do. Think Zero is the name of our pathway to net zero. And I'm going to cover 3 things. Firstly, a bit about the commitments we made and the pathway to net zero. Secondly, some thoughts on what we're doing, what I'm doing, what I see on projects in terms of reducing embodied carbon. And lastly, hopefully, I won't get cut off and run out of time. We'll be talking about just a few thoughts on what clients could do, but also turn that around and ask what developers, what engineers and consultants should be thinking about and challenging those clients on their projects. So are we moving on? There we go. journey so far, so without going into major detail here, Grosvenor have been looking at this and working on sustainable developments for an awful long time, back in 2005 with the Eco Homes programme, all the way through to the green goals that we published in 2019. That forms the basis of our pathway, which was then launched in 2020. So just to talk about those 4 bold green goals, which we committed to in 2019: zero carbon, zero waste, value in nature, and bringing our partners with us. Clearly, the net zero pathway focuses on the first of those. We will soon be launching similar initiatives for waste, nature, and partnerships to ensure we publicly share both the ambitions and how we plan to achieve those goals. And so Think Zero, the pathway to net zero, is in terms of kind of 3 points. Firstly, it shows outputs of some of the carbon analysis, which was done to forecast what our emissions would be between 2019 and 2030 if we didn't act. Secondly, it outlines the targets and tools which we're going to use to reduce these emissions, and so that we can minimize the amount of offsetting we need to do. And finally, it talks about how we will change our business to embed a culture of sustainability. And in terms of that analysis, if we did nothing, then this graphic shows how much carbon we would produce in the 2019 to 2030 period. Clearly, there's 3 big lumps there: supply chain, our buildings, and then developments. So we need to reduce emissions in our supply chain, we need to reduce energy use in our London portfolio, and we need to reduce embodied carbon from our construction development activities. And the key thing on this slide, which just shows how we sort of get there, is the 52% reduction between now and 2030 across those kind of big 3 buckets, if you like. So a minimum of 52% reduction in emissions. That will drastically reduce our carbon footprint. Buildings will be highly energy efficient, powered from renewable energy sources where possible. We'll also minimize the carbon emitted from our development program and created through the activities of occupiers of our properties and our supply chain. Any residual carbon that cannot be avoided, we then offset through verified schemes. And I should also add that by 2050, our aim at Grosvenor is that we are climate positive and plan to take more CO2 out of the atmosphere than we emit. And then turning that quickly onto what that means as a sort of development side, we have a sustainable development brief. All of the coloured boxes there you see are the sort of different categories that covers, but the aim of that brief is to deliver best practice across all of our development projects. It improves performance. We can understand how one project performs against another. We can understand how projects perform at a portfolio level, and crucially, it gives us a means of assessing these and approving within our sort of Grosvenor approval process through an environmental scorecard, where we can effectively move through gateways by showing that on a simple scorecard, our projects are working in accordance with these green goals. So quickly moving on to reducing embodied carbon. The target for embodied carbon on our developments for PC after 2025 is 500 kilograms of carbon per metre squared. This was established having looked at whether it's LETI, REBA 2030 targets, other developers that are leading the way alongside ourselves, and 500 is seen as certainly a challenge, but definitely achievable on most of our projects. I've put the LETI guidance up there because I think that helps put some of this into perspective. 2020 versus 2030 targets, and our 25 target there sort of sits in between. It's definitely a challenge. Yannick just put on a slide on the screen there that had 1600. If you do nothing, you probably end up around 1600. So our projects are aiming to be less than 500. And I'm sure in the future, to Yannick's point about the targets are only ever going to move in one direction and come down. We can't rest at 500. We've got to be thinking about continually reducing that number as best we can. As Will mentioned, I've been doing some work on circular economy and material reuse, and Penny will no doubt talk about the full circle to reuse document that they produced. ORMS, Arup, London, HETA and others all participated in that, and we did some really good work there, looking at how we can better work with the circular economy and actually reuse materials rather than sort of mining new. And I think the industry is kind of quite comfortable now with doing things lower carbon, but how can we move it on again and sort of stop thinking about buying new and think about using the resources that are already available and not downgrading them, so we don't recycle, we reuse. And I thought I'd throw this couple of articles up. At least 4 people on Friday sent me the one on the left. The whole kind of material reuse, demolish, I think is a word that needs to disappear. You know, we should be using deconstruction. We don't talk about it enough at the moment, but I think it's coming. I see this as a big opportunity to kind of move the dial on embodied carbon. And it's kind of coming into the mainstream. You know, if you see things in BBC News, it tells you that the public are becoming a bit more aware. You know, we're going to have to address this. So if you're not doing stuff in this space at the moment, I think it's coming around the corner. A quick mention of Steel Zero, just as another example. I know Matthew is a speaker as well. So, you know, Steel Zero, we're a founding member of that, and this gives us sort of sight across the whole supply chain for steel. And I don't think steel and concrete are going away. We've got to do those better and lower carbon. So this is a brilliant scheme where we are, you know, I'm actively working with this on one of my projects, how we can procure the lowest carbon steel. And then on the SEM-free side, you know, whether it's SEM-free or other cement replacement products, these are all absolutely key in making sure that we have low carbon buildings. And, you know, we need to do these things and employ these kind of products to be able to hit those kind of 500 numbers. A quick mention of things like Mmc and Dfma. You're not going to be able to do all of these things on every project. So I just think it's important to recognize that these are all different things you can do. And, you know, early on as your project kind of evolves and develops, you think about how you could do things differently. Think about how you can employ technology to improve site efficiency, whether it's systemized kind of component assembly, offsite manufacture, all these different things, whether they improve overall project performance, may also help on the embodied carbon side. And we already mentioned environmental product declarations, EPDs, one-click LCA I saw on one of Yannick's slides. This is absolutely critical in making real-time decisions on a project. The better these get, the more informed we are, the better decisions we can make. So again, as you start to develop ideas of what the products are that you're going to be using on a project, you know, make sure we're getting that information through, make sure it's finding its way to the sustainability guys doing the analysis. That will filter through to better decisions. And finally, just one slide on client insight, and I'm going to talk to these 4 points here. So firstly, set the vision early. It sounds really obvious, but you know, these days I think it's not really enough to just say, can we have a sustainable building, please? We at Grosvenor are lucky that I've got that sustainable development brief that I mentioned. You know, that gives a really good, strong framework, ambitious targets that the design team and whole project team need to understand and try and work towards. But I think from a client perspective, you've got to keep pushing this. You've got to keep asking the question, can we do more? You know, I've had consultants asking me what the target is on the project, and I just say, keep making the carbon number go down. You know, don't worry about the target, just make it go down. So, you know, there's no kind of hitting a number and resting. I think from an engineer or a consultant's perspective, you know, make sure you're playing back to the client that you understand this and that you are actively, consciously, all the time thinking about ways to improve, and don't be afraid to offer solutions. You know, they might not all work, but I think the whole industry has always kind of been pretty good at doing what you did before. You know, staying in that comfort zone. So, you know, don't be afraid to step out of that. The second point, encourage innovation. You know, we have a Future Plus scheme internally at Grosvenor now, where it really does encourage us internally to do innovation, and we are passing that on to our designers and asking them to come up with different ideas. So, you that doesn't just have to be sustainability, but absolutely these things sort of naturally, I think, come together at the moment. You kind of difficult to separate them. But one of the things I've seen on that material reuse work I did was that if you put, as a client, a team under time, cost, resource pressure, then everybody goes back to that kind of safe, doing what we've done before. It kind of stifles innovation. And so from a client perspective, I saw the benefit of giving that team some, what we've called a safe space, a little bit of extra time. They also provided resource, and it really did result in good things coming out the end of that. So as a client, it's a difficult one to do, to say elongate the program, but certainly look for opportunities within your project program as where you can allow a little bit of that different thinking, step away from the day-to-day, have a moment, think about, can you do something differently? Is there a different product? From a consultant side, whether you're a director of a company allocating resource, also consider that, can you give a little bit of that the week to thinking differently? And if you're on a project as an engineer or consultant, then also just try and set a bit of time aside to think in a different way, and talk to the client about whether you are under severe pressure, and ultimately reverting to that kind of doing what we know, where there's less risk and less risk of failure. Thirdly, understand where the value is. So I've got two things here, macro and micro. The macro is we're doing this because there's a climate emergency, but we're also doing it as clients because we see this is where the tenant demand is going. People will want these buildings, and at the moment it costs us money to do this. In the future, I think we'll reap the benefit of having the most sustainable developments, and not just being either average or very much below par. So that's the kind of macro value picture. Micro is with EPDs, with real-time decision making. No longer can you do a design stage and effectively mark the score at the end and find out how you're performing in carbon terms. This needs to be real-time, and as a set of consultants or design team, you need to come to a client and say, we need a decision, but that can't just be based on the cost anymore. I want to know the carbon impact of that decision, as well as the program, the cost, and the sort of standard things you've seen before. And we're not going to be able to do everything on every project. So if you can see that and you can bring those factors into a decision that a client can make, then you can pick the right thing for that project. So I think there's a big balance there, but having all of that information to hand at the right moment in time allows quick decision making, and you can move through sort of project gateways. Finally, Will, I know I'm at more or less 15 minutes, but challenge procurement. So I see this as another massive opportunity. Procurement is complicated. We've got a really tricky supply chain that we deal with, but we're definitely sort of entrenched in the way of specifying and drawing what are effectively new products. The design team do that. That's just the way we know, and the contractors go out and price it because they know they can buy product X in a lead time of Y. We need to switch that up, and I'm thinking here about material reuse and things. That has to change. The model has to change. It won't change overnight, but we can certainly perhaps think about how we deal with risk and who wants to hold that risk. Can a client hold more risk to allow that supply chain to flex or act in a different way to allow us to go and procure some secondhand materials from another site? All of that needs to kind of unpick itself. I think we're deeply entrenched in doing what we know there. So whether you're a client thinking about that or a consultant and you've got different ideas, or you have another project where something's available, step up, suggest that you might approach a package of works in a different way, and see if you can explore that a bit more with your client and do it early. Well, I'm probably about on time there, so I'll stop.
No, very good. Thank you, Steve. Yeah, and really enjoyed that last slide: vision, innovation, value, and procurement. I think if there's one thing engineers could do, it's to go and speak to your clients about how you get more of those on your projects early on. I think it never hurts to ask, and I've heard many engineers say how surprised they were when the client turned around and said okay to requests such as those things, because the engineers assumed it would be an obvious no. So always worth asking. Thank you, Steve. Just before we move on to Caroline, just a quick reminder to you all, do please start putting some questions into the chat box. We've had one so far. It'd be great if we got a few more. I've got a whole host of questions I've started writing myself, so we're not going to be short of discussion points, but if you've got anything you'd like to ask, please do put it in the chat box as we go through the final 15 minutes with Caroline. Caroline Field is an Associate Director in ARUP's Resilience, Security and Risk team. She's also Royal Academy of Engineering visiting Professor of Structure and Infrastructure Resilience up at Loughborough University. So nobody really better to come and speak to you about risk and resilience. I get, risk is a massive topic, lots of aspects to risk, from financial to climate to human safety. So really looking forward to hearing your take on all of this, Caroline. Over to you.
Brilliant. Thanks, Will. And thanks for inviting me. Great to be here. And as Will mentioned, I'm actually a structural engineer by training, but I do more around organizational resilience, so kind of advising clients how to build their resilience, especially given what we've been going through the last 18 months. So I'm going to kind of talk a little more broadly than just climate risk, but obviously that's obviously incredibly important and top of our agenda. But as we've all noted, we are living in an increasingly VUCA, so volatile, uncertain, complex and ambiguous environment. And we really need to better flex with that volatility and help our clients adapt in the face of uncertainty and embrace that complexity. So, lots of things going on that kind of influence our designs, and we really need to think very broadly in terms of systems. And my question really here is, are our current design methods appropriate for the kind of to make our buildings and infrastructure future-proofed? Are we ready and fit for the future? And so I think we need to be talking to our clients about these types of issues. And obviously we're talking about the impact of climate change on design, so having that conversation up front. But thinking about, well, there's a lot of assumptions embedded in what we're designing in terms of, how our building's going to be used. Lots of things are going to be changing over the lifetime of the building. What happens if some of those assumptions are exceeded? Do we understand how our buildings fail? Do we understand the consequences of those assumptions being exceeded and what might happen? And do we also understand how adaptable our buildings are? We talked about that previously. And this is something we really need to be thinking about. So we want to better reuse and adapt from a sustainability point of view, but also from a resilience point of view. It needs to be flexible, be able to adapt to changing conditions or changing design aspects. And so I think what we should be thinking about more is really starting to stress test our designs and think about different scenarios for the future that we might want to be incorporating into our designs as we move forward. So I always want to talk about resilience by defining resilience because it does mean lots of things to different people. So capacity of cities, individuals, communities, institutions, businesses to survive, adapt and thrive no matter what kinds of chronic stress and shocks. That's Rockefeller. This one's probably my favorite, the ability to prepare for and adapt to changing conditions and to withstand and recover rapidly from disruptions. And the shortest and sweetest, the ability to absorb and adapt in a changing environment. Just draw your attention to the fact that I think as engineers, we very much think about risk and mitigating risk. So it's a specific incident we're designing for, so withstanding and recovering from a specific event, but also this ability to adapt to changing conditions, I think is incredibly important. And when you think about what we went through, or what we're still going through in some sense with COVID, nobody was prepared for that size of event. And so everybody had to adapt. We all had to adapt to working from home. So that's why it's incredibly important that we don't just design for things that we can think about. We kind of need to design to be adaptable and to think about this uncertainty and to prepare ourselves for that. So, and when we think about risk and resilience, I think people get a little confused by that. So just, a way to think about that as engineers, I think, is, traditionally we very much think about sort of a single hazard when we're thinking about designing for risk. When we think about resilience, we're dealing with multiple hazards. We're dealing with what we call shocks and stresses. So there's kind of low-lying kind of things like, well, say climate change would be a stress, causing a shock like an extreme weather event, for example. And then with risk, we tend to know what those risks are. With resilience, we don't necessarily know. So we're dealing more with unknowns and uncertainty. And with risk, we tend to be sort of focusing, I think, more on a single asset. But with resilience, we really want to be thinking about the system as a whole because of the interdependencies between systems. So the questions we like to ask, and I think it's good to ask our clients this as well, is resilience for what? What's the purpose of what we're doing? Of what? What's our system that we're making resilient? Resilient to what? and for who as well, actually, because it's who's actually benefiting from this. And that certainly comes into play when we're thinking about broader sort of city resilience and national resilience. So as I mentioned, for what, the purpose, of what systems and the interdependencies of those systems, your shocks and stresses and scenarios is your to what, and then who's benefiting from this, what's the value that comes out of this. So really important when we're thinking about resilience is thinking in systems and not in silos. And so because we're so interconnected now, you have to understand those dependencies, and you also have to think about systems aren't just physical, so it's not just a building. You have people that use that building, you have virtual systems that come in, you have governance systems, and so everything is interconnected. So kind of being able to think in terms of systems and understand those interdependencies is incredibly important. And I think as engineers we need to kind of think more broadly about not just about our specific building, but think about, oh, this is actually part of our client's portfolio and our client is trying to achieve X, therefore, you know, this is what this needs to do, rather than just kind of, you know, designing a building for to meet code requirements. It's really understanding what's the purpose of this building, what performance does it need to deliver, and what's our client looking to do. So when we're thinking about sort of buildings, for example, obviously so many different design aspects of that building, and a building can't be resilient on its own if you can't get to the building. So if your access or transport or your staff can't get to the building, your building won't function. So it's not resilient. So it's not just about that kind of physical resilience. We need to think about these other systems that come in and think about people as well. So just thinking about a few sort of design considerations when we're kind of trying to set the brief and influence that and talk to our clients. So, you know, if you think about a project right at the start there, we're kind of defining and planning. And so we want to be understanding who the stakeholders are in our project, how is our project organized, what system are we looking at, what is that kind of extent. You know, we're looking at maybe one building, maybe it's a master plan, but there's a boundary there and there are interdependencies across that boundary. So we need to understand what that is. We need to understand what outcomes, what are those goals that the client is trying to deliver, and what performance do they want. So how willing are they to be disrupted, and what's the risk there, and what's their budgets. And so it's not just sort of a code-based design, which is really there to you know, protect life safety. This is about performance of their asset and of their business potentially. And then when we're designing and delivering, we want to understand those interdependencies that our building or infrastructure is relying on, how that will affect the project, what are the design solutions that we could incorporate for resilience, what's the business case to do that, what's the cost benefit of that, because resilience isn't just necessarily building stronger. There are other things we can think about in terms of response, recovery. It might actually be, your client might actually be okay with some level of disruption and some downtime, but we need to understand what that is so that we can design in appropriately and think about all of those pieces. And then the operate and maintain, we don't often kind of have this joined up thinking, but obviously somebody's going to be running this building. What are the operational solutions for managing resilience? If an event does happen, whether it's an earthquake or a flood, how easy is it to repair that damage? Are there local materials that can be brought in to help fix that? How easy is it to adapt to changing conditions, new technologies, changing demographics, whatever it is? How easy is it to do that? How easy is it to reuse this building? And lastly, thinking about monitoring. So using kind of structural health monitoring to understand how our building's performing and whether it's been damaged, say in an earthquake, for example, or using that as an early warning system for events. So there are lots of aspects of resilience we need to be thinking about. And as Steve mentioned, I think this question of, you know, for what's the purpose, what value, thinking really broadly about the value that the project is delivering and understanding that from the client. What do they care about? Because ultimately resilience is there to deliver those objectives. So if you don't understand what those are, you're not really understanding why you're designing resilience for that client. And so really understanding what those kind of drivers are for them, and that, you know, very broadly in terms of, you know, economic, social, environmental, financial, drivers, which is what's taken me to organizational resilience, is really sort of understanding the business behind resilience so that we can then design the assets and everything else to kind of meet those requirements. And that leads into obviously performance of a specific asset, so understanding different levels of hazards and what performance, what downtime is often a performance indicator of resilience. How much loss can you accept? How much downtime under a specific event? And then, what does that cost? What's the risk of that event happening? And so it's a kind of risk, cost, performance conversation to have with your client pretty early on in terms of understanding what they're trying to achieve. Because, for example, if you're designing for an earthquake, codes designed, as I mentioned, for life safety, but that could mean the building's out of operation for a year because it has to be rebuilt. How will that impact their business? And I mentioned systems. So this is a project I did with Bristol Airport, actually. And so kind of thinking about the airport as a system. And this one, and I don't expect you better read all this, but just showing kind of thinking about all the components that need to happen in order to get people into the airport and onto a plane to their destination. And what could disrupt that, and what do they need to do in terms of decision making about where should they invest to increase their resilience. And this one's actually power over here, and we've done some work subsequently on improving their energy resilience. But by thinking about it in a systems way, you can kind of, I mentioned bring all this together in terms of the goals, the risk to the system, thinking ahead in terms of what risks might be coming, understanding those interdependencies. So the size of the bubbles on this one are actually the importance of these functions for delivering value to the client. And then we've overlaid that with a suite of kind of risks and a capacity assessment on all of those functions so that you can really understand where the resilience is needed within this airport as a system. And that then helps quantify the value at risk to that client and the strategies that would be best used to keep that airport going and deliver on their goals. So thinking very broadly about their organizational goals. And then resilience to what's, this is where we come back to risks. So the risks we do know about, so kind of thinking very broadly about those. So from, pandemics through to security risks, changing technologies, societal risks, infrastructure, aging infrastructure. There's a lot to be thinking about. And right up front of the project, we can be informing our clients in terms of thinking about where they're going to be siting their next asset, for example. So what's the particular sort of risk exposure to that location? And there's some sort of geospatial modeling we've done for Tashkent, and thinking about the different kind of shocks and stresses and where would be best to, what it's like to cost them to, and choosing different site locations, for example. And then thinking, like I mentioned this kind of multi-hazard thinking. And so this is a project we did in Beirut. So looking at the kind of full spectrum of shocks and also stresses, and just kind of prioritizing kind of what we need to do about those. So really, rather than thinking, as I mentioned, sort of single risk, thinking very much sort of all the risks that could be affecting our client and their assets. And then thinking about, I mentioned adaptability and change. So kind of what could change over the lifetime of that asset. So where, obviously we've got changing technologies and changing systems. How easy is it to upgrade? How easy is it to, keep abreast with technology within the building? Usage, how adaptable is it for different usage? How resilient is it to changing loading conditions, whether that's storm loading, flooding, or whatever? Processes, changing processes in terms of how we work, changes in mobility, changes in demographics. So thinking about how adaptable does our building need to be for the future. And this really leads us to performance-based design. And so understanding how our buildings perform under different events. And so this is actually showing, this is looking at terrorist threats, so looking at blasts, performance of the blast for this specific building. And this can really help quantify and help a client understand what they need to design into their building, what level of downtime they are willing to tolerate, and what we can design in versus what they're prepared to kind of respond to and recover from. And so this really answers the question for me. I think right now as engineers, we don't necessarily know enough about our buildings and what happens if the design assumptions are exceeded. And this is a way to understand that by understanding how our buildings fail. And that's exactly what we do in blast design. We look at a sequence of failure, so making sure that your glass fails before your mullions and your mullions fail before your connections, and so you're kind of looking at that sequence of failure so you don't get progressive collapse and this cascading failure. So I think the use of these types of tools and analysis can really help inform us about our assumptions when we're designing and how our buildings actually perform and how resilient they actually are. And then lastly, I just want to leave you with thinking about, once you're designing, thinking about resilience capacity. And so it's not just about building robustness, it's about trying to prevent the risk in the first place and avoid being there. So whether that's through this risk-informed planning, we obviously can design robustness into buildings, we can design redundancy into systems, and this fail-safe I just mentioned about understanding and making sure that if something does fail, it doesn't cause other problems. And then on the other hand, on the other side is what we call adaptive capacity. It allows us to adapt to the things we don't know about. And so being aware and having monitoring systems and being able to getting information about what's actually happening outside and early warnings, for example. And then adaptability, as I've already mentioned, how easy is it to upgrade? How can our buildings and people within those buildings respond? Thinking about how they're going to be evacuated, for example, and how then can we recover those and recover those performance, and a lot of that goes to the building materials that we choose and how easy it is to do that. And then lastly, being able to obviously capture, learn and improve as we move forward. So these are all aspects of resilience as we design. Thank you.
Yeah, thank you, Caroline. And really, again, a really good whiz through what's a massive topic. We're going to move on to Q&A now, and I'm actually going to start with you, Caroline, if that's okay, because we've had a few questions through that all grouped together quite nicely around the balance between sustainability and resilience, as it were. So Chris Price, Anna Clisham, Yasmin Atkas, and Rosie Ramsey have all asked a variation on the same question. So we've got a question around using novel materials, which is lower carbon maybe, but higher risk. We've got designing in extra strength and robustness now to avoid rebuilding later, but at the expense of extra emissions today. We've got lean design, which would minimize emissions and therefore minimize effects of climate change, versus resilience against the effects of climate change. What are your thoughts on getting that balance right, which is a very difficult question without one particular answer, I imagine?
Yeah, I did do, I think you'll remember I did an article for you guys on lean versus resilient. And so as designers, we always have competing commitments and competing kind of requirements, and it's really understanding and prioritizing what the client is trying to deliver and be able to advise them in terms of, okay, well, here are the trade-offs, what's the thing that's kind of almost most important, and so kind of weighting those. And I will say, in terms of, there are so many synergies between sustainability and resilience, and I chair a group at the moment that's actually writing a paper about resilience and sustainability and how they can, both need to be part of design and how you try and do that. So it's definitely a key topic at the moment. I mean, I think from this lean perspective, I think lean is really about better ways and more efficient ways to work, not just to design. And so I think just thinking about the physical design is a bit limited. I think you need to think about how you work and the efficiencies in that and the kind of long-term pieces. So I don't think it's just about the robustness of the materials as such. In terms of actually, maybe I'll stop there for a second, but I don't know if that was helpful. I can't really answer it's difficult to answer a question, and there are always tensions. All I can say is it's basically understanding those trade-offs and understanding what your client, what are the ultimate value that you're trying to deliver and goals that your client wants.
Yeah, I try and think of carbon investments and whether they're going to be worth it. So is it worth emitting more carbon today in order to achieve such and such a goal? And it's going to be project specific, isn't it? It's going to depend on the client, it's going to depend on the project, where it's located, what the risks are. But we have to have these conversations.
But I think it's important to think, it is really important to think in that systems way, which means you're thinking about all of these consequences of these decisions, not just kind of, you know, being very rigid about, well, we have to do that. And it's like, well, actually we want to do that, but also we also want to do this. And so it's being smart and trying to come up with those solutions that obviously have co-benefits. So, you know, you can build, you know, a flood wall and you can make that out of concrete, right? But that then doesn't have the benefit of, you know, if you'd have designed a beautiful environmental, you know, green area that can absorb the water and be a park. And so what we're trying to do when we think about resilience is thinking about those co-benefits and be able to design those other items in. I think that's really the important thing for us to be thinking about as engineers.
A bit more holistic. Yeah, that makes sense. Thanks, Caroline. Yannick, I've got two rapid fire for you. A couple of questions, one from John Frieden and one from Andy Bayliss. The first is your thoughts on carbon taxation. Is anyone doing it? Do you think they should be? And the second question is, do you have any comment on the definition of net zero, and specifically the fact that government policies often involve reliance on carbon capture, maybe international offsetting in the future? Does that align with what we need to do? So carbon taxation and net zero.
Okay, great. What I'm going to unhelpfully do, Will, is answer a third question that's directed to me first, because it leads on to the other two. So someone in the chat had put one asking about the time frame for cleaning up the concrete and steel industries. If you want some good resources as a kind of overview of what's going on that, I'd highly recommend the Green Steel Tracker. I'll drop a link into the chat box afterwards. And then also the Global CCS Institute retains an active database of all the projects that are going on in that space at the moment. The sort of short answer to that question about, you know, are they doing enough on concrete and steel is, there's an awful lot of activity happening. Far more has been announced over the last 18 months than in the previous decade, I would say, in terms of initiatives. But all of them are on a time frame that's, you know, multi-year time frame to roll out these kinds of assets. And that means that in the near term, we need to be focused on reducing our use of those materials where possible to facilitate that kind of transition going forward. If you think about a challenge like the UK, for instance, even though we're doing all these kind of CCS hubs, regional kind of hubs around the UK that we're planning on developing, you've got somewhere in the region of 4 million tonnes of emissions from cement plants that are in dispersed sites, which we still have to deal with afterwards. So if you imagine a site that's, you know, 150 kilometres from a port, are you going to run a big pipeline through to there? Are you going to transport it by road in lots of tankers? You know, these are incomplete solutions at the moment, and there's something that we're still very much developing. That feeds into the pricing question in that, you know, we do have an emissions trading system in the EU, and the UK's still maintaining a sort of equivalent now that we've left. That's about 50 quid a tonne at the moment. Of course, there's various exemptions and allocations and so on that really impact on how effective that is. There are lots of companies voluntarily now applying carbon pricing within their own projects and portfolios. If you want some great examples, I'd have a look at the Carbon Pricing Leadership Coalition, which is a group of companies that are doing exactly those sorts of activities. The problem, I'd say, for the construction industry as a whole on that front is you need really high carbon prices before it trickles through to the point where it affects design choices, generally speaking. So I was involved with Arup writing a report for around kind of carbon pricing and infrastructure value chains a few years ago. And by and large, the kinds of carbon prices that are out there at the moment were at such a low level, with the exception of some of the voluntary ones, that they weren't impacting upon the kinds of decisions of what was being specified and so forth. Now, that might change in future as those prices rise. And we've seen a lot of really positive moves, I'd say, in the last 12 months, things like reassessing the values that are used in UK policy context, so the Green Book guidance and the values that are used there. But implicitly, all of our assumptions around this are still based on the idea that those prices will really accelerate through the 2030s and go up massively then. I think there is a risk that disincentivizes early action today, with the idea that a tonne of carbon in the future is going to be worth quite a lot more than a tonne now. Whereas from the planet's point of view, obviously, it's a cumulative emissions problem. The ton today is very important. How we deal with that in policy circles, I think it's tricky, and you're seeing some more innovation on that of late. I think I answered 2 of your questions there, and I forgot what the third one was, but I think it was around the net zero. But I'll let the other 2 come in first, and I can.
Yeah. Okay. Yeah. Thanks for your thoughts on that. No, that's really good. Steve, we had quite a wonderfully straightforward question for you, which is along the lines of why are Grosvenor doing the things Grosvenor are doing? Why have you set a target to halve the emissions of everything you get built by 2030 and then plan to offset the rest? Is there a financial reason for it? Is it just because it's a nice thing to do? Maybe you could give us a bit more of an insight, I guess, so that our listeners can go away and try and convince their clients to do the same thing.
Yeah, no, I think I'm reading the question there. So I think maybe I'm a bit cynical. Is it because you're doing the right thing? Well, I mean, I think we are doing the right thing. We firmly believe that, and we want to be an environmental leader. Aside from that, I do think Yannick's point there on value is a massive one. I don't think we value buildings in the right way at the moment. We're kind of like look backwards at and that kind of goes through a standard process, and we get a value for the building. I think we're going to move in the future to have other factors that give us the value of a building. The quantity of materials in there, the ability in the way you might be able to deconstruct it, will add value to a building. The credentials of how it performs will make it more marketable, lettable, saleable, etc. So I think for us, we see that bigger picture. We're doing it for the right reasons on the climate emergency, but we also see that's where the market, the built environment will be going. So yeah, does that answer the question?
Yeah, no,
I guess there's other reasons in and around that, but I see the value as being a massive part.
Yeah, and it sounds like you're just taking a much longer term vision that beyond just talking about what are we going to build in the next 3 years and how can we sell it on, but you're saying what is the market going to be doing by the year 2030? What's going to be expected of us if we try and sell a building or lease out some office space? And I guess that all ties in with sorts of things Yannick is saying about, policy that's out there at the moment is only going to get more stringent, be brought closer to us. By the time we get to 2030, we're going to be talking about very different things to what we're talking about today. So it sounds like you're sort of quite well aligned with that thinking. Yeah,
and Grosvenor are in a privileged position to take that long-term view. That's what we do. We've been around for 300 years, and we aim to be around that long in the future, if not more. And that kind of you have an estate, you curate that, you're the custodian of that estate. You want to make long-term decisions, and I do appreciate that there are other developers out there that take a shorter time frame and shorter outlook, and I think that is where some of the challenges lie. And one of the questions was around how do you kind of deal with that? And I think education is one thing, trying to help those people understand that something that we do today is actually going to be more valuable tomorrow. But it's definitely a challenge when you've got a much shorter term horizon. Yeah.
And Caroline, does this sort of feel? I can see you've unmuted yourself. Does this sort of tie in with that thing you're saying about longer term risk and resilience plans?
Yeah, no, absolutely. I was just going to add actually, and I'm sure not to steal Steve's thunder here, but Grosvenor have a track record of being ahead of the game here, because they were looking at resilience 10 years ago, and so they were one of the first to kind of look at resilient cities and where their assets were, and the risks and kind of long-term resilience to those locations, so they could make investment decisions. And so they do see it as good business as well as the right thing to do, and this long-term view, I think, is what we need to try and talk to our clients about, and show examples as well of other, and obviously Grosvenor is a successful business, and they're still doing all the right things as well. So
exactly.
It's
you can do both. Yeah.
So great, good job, Grosvenor.
Yeah, thanks. Okay, look, we're going to go to a break now. So I want to say thank you, Yannick, Steve, and Caroline, for your excellent presentations there and your extra thoughts on the Q&A. Sorry to everyone that we didn't get through all the questions. This is what happens when you're not first to write your question in the chat box, I'm afraid. We're going to have 10 minutes. Just go and get yourself a cup of tea or go and stretch your legs, do what you need to do. And then at 10:30 British summertime, or if you can call it summer, whatever time it is in the UK, we're going to meet back and we're going to go on to talk about carbon. We've got Christy and Susan talking about whole life carbon and talking about carbon targets. So hope to see you in 10 minutes. Thank you.